Welcome to the time bases of the HT8 MCU basic tutorial. This course will take you to understand the time bases of the HT8 MCU from the following 5 aspects, which are time base introduction, time base structure, time base configuration, time base independent interrupt, and application examples. Time base introduction. A time base can be understood as a simplified version of timer, which has no operating modes and is only used to generate an interrupt signal at fixed time periods. In the time base, the counter timeout values have been fixed, and only one of the existing schemes can be selected as the counting period. After each clock pulse passes, the counter will be incremented by 1. When the counter reaches to the timeout value, it will overflow to ring and generate an interrupt signal. In general, the time base is a timer designed to generate a time base interrupt signal at fixed periods. The time base interrupt signal can be used to trigger a time base interrupt. The time base is commonly used for timed task execution, such as timed wake up, timed light on, off, and so on. Time base structure. Taking the HT66F3195 time base structure diagram as an example. The time base structure can be divided into the following 4 parts according to its function. The first part is time base clock source selection, which is used to select the clock signal. The second part is time base on/off control, which is used to turn on or off the time base. The third part is time base interrupt period selection, which is used to select the period of time base interrupt signal generation. The fourth part is time base interrupt signal, which is used to trigger a time base interrupt. It should be noted that in the above diagram, X stands for the time base serial number, which may vary in different HT8 MCUs. The HT66F3195 has 2 time bases, TB0 and TB1, therefore X can be 0 or 1. Taking the HT66F3195 as an example, the time bases of different devices may vary. Refer to the corresponding datasheet for details. Time base configuration. We have just learned the time base structure. Next, we will learn how to configure a time base. First, select the clock source for the time base. Then, select the interruption period. Finally, enable the time base function. In this way, the time base interrupt signal can be generated at regular periods. Taking the time base 0 as an example, how to configure the interrupt period to 0.512 seconds. The time base configuration involves 2 registers. One is the PSC0R register, which can configure the time base 0 clock source. The other is the TB0C register, which can set the time base 0 interrupt period. Its value range is related to the time base 0 clock source. Step 1. Select the clock source for the time base. The HT66F3195 uses a 32 kHz low-speed internal RC oscillator by default. Here we select the low-speed clock as the time base 0 clock source, therefore the CLKSEL01 and CLKSEL00 bits should be set to 10. Step 2. Select the interrupt period. Let's first calculate the division ratio. We have already set the time base 0 clock source to 32 kHz and the interrupt period to 0.512 seconds, substituting them into the calculation formula to obtain the division ratio. Then, select the interrupt period. Finally, enable the time base function. Time base independent interrupt. According to the datasheet, the time base interrupt is an independent interrupt. The HT66F3195 provides 2 time base interrupts, namely time base 0 interrupt and time base 1 interrupt, both of which have the same function. What is the purpose of a time base independent interrupt? It can be used for timed task execution, such as timed wake up, timed light on, off, and so on. Now let's take a look at a time base 0 independent interrupt example. First, define an interrupt service routine name. Then, use the lookup table to obtain the interrupt address. An independent interrupt corresponds to a unique interrupt event. The interrupt event can be handled once the interrupt is entered. Application examples. Taking the time base 0 as an example, how to use the time base 0 interrupt to implement LED blinking. First, set the time base 0 period to 0.5 seconds and enable the time base 0 interrupt. Then, set the interrupt service routine to toggle the IO level of the LED, and the execution content of each interrupt is to change the status of the light. The time to complete a blinking is 1 second. Let's take a look at a program example. We write the main program first. First, initialize I/O, including setting PA1 as an output with initial high, and configuring the relevant pin functions to use the external low-speed oscillator. Next, select the external low-speed oscillator as the low-speed clock source. Next, configure the time base 0 as required. Enable the time base 0 interrupt function and enable the global interrupt. According to the solution, write the main loop program. We then write the interrupt service routine. When a time base 0 independent interrupt occurs, toggle the PA1 level state to implement the LED blinking. Course summary. In this course, we have learned about time base introduction, structure, configuration, and time base independent interrupt. Through the study of this course, you will have a clearer understanding of the time bases. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.